Hello folks, I've just brought the flywheel back from the water jet company. Let's have a look what we've got. Here we are. We've just had this unusual shape pulled out of the middle of it. Let's put it in there. That goes in there. Right, so the water jet produces a 1.5mm cut all the way around there. Okay, we take that part out. Take that part out there. And we now have, if you look at it, an Archimedes spiral there, one there and one there. Okay, now the special about Archimedes spiral is, as you turn round a degree, the distance from the radius increases by exactly the same amount in millimetres for every degree. So that's the definition of an Archimedes spiral. It's special because this happens. I've got a piece here that we're actually going to fit inside it. Now this piece fits in here. Okay, just drops in. Okay, and then as we turn this, it tightens up all the way around in one go, just locks in. Okay. That's the Archimedes style. Right, now the basic problem we have is that we want to make a flywheel that you can easily take on and off. But the water jet has this problem. Here it is. If we put that against there, there's a slight, you can't hardly see it on the camera. It's not quite flat. So if we make a cut and push this in with a 1.5mm gap, and turn it, it might stick this side, but the taper's wrong and it won't stick the other side. So this piece has been manufactured the other way up. This is better. I probably didn't hear that because of the clanging. This piece has been manufactured the other way up. So this time, this piece increases clockwise, and this one decreases clockwise. So this is a clockwise spiral, if you want to have the definition, and that's an anti-clockwise spiral. So what you do, you cut them like that, and then the taper is in the opposite direction. So you turn it over, and suddenly that's clockwise. So that fits in there now. Okay, and you turn it that way, anti-clockwise, it locks. Okay, so that's how we're going to hold the flywheels on, and it's much better than a conventional technique, because you have to rigidly bolt the flywheel on a tight shaft to make sure it doesn't vibrate and doesn't move its position. And this one allows us to get the position exactly right. Okay, now to get that, I've got a small sample here. I can work on this one, easy for you. Right, so we've got the same thing, only handleable. I can't lift that one. So let's just find top dead centre for that one, and top dead centre for that one. So that fits in there. Right, now let's think about what's going to happen. This is going to be on your shaft. So you've got your shaft on your machine, and this is going to be your flywheel. So you're going to offer your flywheel up like that and just drop it on easily. So much slack it'll just drop on. Hardly needs any slides mechanism. It just pushes across and goes on like that. Okay, now I'm going to do it down this way, and I'm going to drop this one in there. It's only the same really. So you drop that in there like that. Okay. Now what you do is the flywheel. This is going to be stationary or on the shaft basically, and the flywheel is going to turn. So you're going to push the flywheel around like that. Okay, there's a couple of marks there which show when it's lined. Get that onto the camera. Okay then, there's a top dead centre there as well. Okay then, oh, that's not right. So that, now at that point, we know we've got the flywheel in the right place. So what's going to happen is, we're not going to take the spiral any further than that, for some good reasons. I'll explain that in a minute. So what we're going to do, we're going to go to there. Now we know at that point that the flywheel's in the right place. So we're going to bore 3 holes in here and put sleeves down them to locate the flywheel. So this is basically a positioning device. It's got once it's bolted down, once the flywheel is bolted down, it's not going to be taken any further part in the process. Okay, so right now, so we've got some little problems to overcome, and the first one is we've chosen this curve very carefully here. That curve there is 3 degrees. So in other words, so that curve there, well, let's move the angle, so that when you push it through, there's a 3 degree taper. Now that's exactly the same as I've got one here, a Morse taper. Just in case you don't know what a Morse taper is, that's a Morse taper. Okay, now that's a 1.5 degrees slide either side, 3 degrees included angle. So that grips here. This is a tail stock. Push that in there, and it's solid. It really can't turn it. It's really tough. Okay, and then when you release it, turn the handle backwards, and it pushes on a rump at the back of there. So while it's won't even lock now. So wind it forward. Wind it forward. Lock it in. Okay, now we want the same principle here. So what happens is, in our case, we're just going to push it round. Now, it is possible that somebody can go like this. Okay? Oh, not done it well, not done it tight enough. Still not tight enough. Let's try really hard. Let's put the screw. Let's see if we find a screwdriver so we can drag it in faster. Nope, still not flat. Let's try again. Right, that's nice and tight now, so I can't push it out. And if you look carefully, you can see it's moved about 1 millimetre, which we can work out exactly how much tension there is there, but we don't need to. Right now, so when you get that situation, if it's on here now, we get round that by. We need to tap it round clockwise. Put that in there. Put that in there. Let's free it up. Okay. Now we need the same facility when it's up here. So that's what these 3 holes are for. So what happens? We're not expecting it to jam in, but if it does, we have a tool which fits in here with a prong on the bottom, with a lever on it and a long arm. And what you do is you put the arm in and you go like that, and it pushes that like that. Okay, to release it. So we've got a release. If in case it gets jammed, we've got a release. Okay then. So that's basically how it works. We put the 3 sleeves in, and we also put 3 bolts in to make sure that the flywheel's locked to the fastened to the hub. Okay, so that's the way it works. That's just conventional stuff. Okay then, right. So now, well, we just think it's just beautiful. This really good solution. Okay then, some funny little problems. One of the funniest problems we had was that if you take that out and move it round 1/3 of a turn, like that, it should lock in there. It does, but it's not quite as good. It's pretty good, but it's not quite as good as the fit the correct way around. Okay, that's the correct way around. Wrong way up. Correct way around is that way. Correct way around is there. Inside there. Okay, it's nearly good. When it's that way around, it's the correct way around, which is there. It literally, you can't. It's just absolutely solid. I don't know whether you can see the light through it. Let's see if we get some bright. Oh yeah, if I move it, you can just see a bit. Oh, you can't. There's a little bit of light there now, and it all closes up at the same time. I don't know whether you call that on a film or not, but basically it seals along there, it seals along there, it seals along there, and because the tapers are the same, it seals along there, and along there. Okay, so that's it. So it's just beautiful. We love it. Okay then, so basically what you do is you end up with this on your machine. The flywheel sits here, so it's got to sit there, away from it. And then you bring the flywheel in, put it on there like that, which is dead easy, all loose. And then you turn the flywheel round to centre the flywheel. Okay then, so that's how the principle works. Okay, now were there any other problems with it? Okay, I think that's it now. Oh yes, final thing, this piece is, we actually made, you see we could have made, there's a left hand and a right hand flywheel, so we could have cut that another one of those the other way up and used it there. But in this case, we haven't got 27 millimeters to move the flywheel out of the way because the machine's already built. We've only got 15. So we've made a piece 15 millimeters, especially for there. So that piece fits in there. Again, it was cut anti-clockwise instead of clockwise. Okay, so that fits in lovely. So that's why that's smaller. But just don't forget, it doesn't carry any stress. It's the stress carried on the pins that hold the flywheel in. Okay then, so I think that's about it. I'm really pleased with good solution.